the purpose of this lesson is just to simply go back through angle definitions, angle properties, angle rules, rules that all apply. We're going to start off with single angles first. We remember the four basics. We have an acute angle, which is less than 90. We have a right angle, which is exactly equal to 90. And to show that it is 90, I can't just go by what it looks. I can't just say, oh, it looks like it's 90. Because what I would tell kids is, what if it was 89.5 degrees? The only true way we know it is 90 is if A, we calculate for it, or B, somebody identifies it with a box in the corner of it to prove that, yes, by definition, that's a right angle. So this is equal to 90. Something bigger than 90 is obtuse. If I get my arrow right. So this is greater than 90 degrees. And obviously it's got to be smaller than 180. And if I have a straight line, people say, well, that's not an angle, but what if it was? What if the vertex was there? This would be a straight angle. Which is equal to 180 degrees. All right, by the way, I forgot to mention that the corner of each angle is a single point, which is called a vertex. It means the corner, the intersection of two pieces. In an angle's case, it's the intersection of two rays. So again, these are my four basic: acute, right, obtuse, and straight. Next up, we're going to look at pairs of angles, and the main two we're going to look at is equal to 90 and equal to 180. So the names become a little bit important for that. All sorts of shapes have different angle properties, and this lesson is built to figure out what are the rules. And they're in your blue book under the geometry page, has all the different rules for the different angles. That's what a lot of geometry is what is the rule. Okay, this is equal to this, so that means this is equal to this. So, we talked about the basic angles already. Let's just talk about a simple triangle. I don't care if the triangle looks like this. I don't care if it looks like this. I don't care if it looks like this. What you have to understand is every triangle always has three angles. That's the definition of a triangle. And no matter what shape the triangle is, if you measured every angle in a triangle, you would always get 180 degrees. Simply said, every triangle is worth 180 degrees. The next piece of this is we're going to look at pairs of angles. Two angles that go together to form a definition. The first two angles are two angles that fit together to make 90 degrees. These are called complementary. If you take a look at what these two angles form together, they make a right angle, indicated by the box. So complementary is equal to 90 degrees. Now, a point to make here is this. They don't always have to be side by side. They don't always have to be connected to make 90 degrees. For instance, let's say this angle is 60 degrees, and if they are complementary and add up to 90, this one has to be 30. I could have two separate angles. I could have a 60-degree angle here, and I could have a 30-degree angle here. These still are complementary angles. They go together to form 90. So don't feel it always has to be joined together to make complements happen. Okay? Supplementary is equal to 180. Same concept, two angles that go together to form a certain number. Now here's where it helps to remember which is which, because kids always forget. Complementary is 90, supplementary is 180. Which is which? They both sound similar. If you look at just this bottom angle, we know that it's equal to 180. We know that it is what type of angle from just previous? It's a straight angle. So the easiest way to try to remember is a straight angle is supplementary. So you can try to link the S's together and say straight angle is supplementary. All right, there are other ways to do it, but I find that's the easiest. S ties with S. Again, these don't have to be joined together. They don't have to be side by side, by the way, which is called adjacent, angles that are side by side, sharing a common vertex and a common ray. They could be separate, so if this one was, we'll make it easy, 150 and 30. Again, it could be 150 is here, and 30 is here. They don't have to be adjacent, they don't have to be connected in order to be called supplementary angles. So, two simple ideas, easily confused. Next pair, still dealing with two angles. Next pair is vertical angles. If I take any two lines and intersect them, I am always guaranteed to get four angles. That's just the way it'll work. So let's say I have an angle up here. I'm going to call it angle 1. I don't know how much it is, I just know that there is an angle up top, angle 1. This angle is angle 2. This angle is angle 3 and angle 4. Why did I number them this way? Just because I needed something to put there. I could have put A, B, C, D, something to represent a number even though I don't know it. Now what vertical angles mean, they are back to back. Sometimes we say they're opposite of each other. The biggest thing we have to understand is that they're equal. So angle 1 is equal to, well, what angle is back to back or opposite of it? Well, here's angle 1, the opposite is angle 3. So angle 1 and angle 3 are equal because they are vertical. Angle 4 is opposite or backwards of angle 2. If it was a piece of paper and I folded it, they would be equal. How do I use this? Okay, let's say this. Angle 1 is worth 120 degrees. Oh, well, what's angle 3 worth? Well, it's equal. 120, 120. I could go further and say, oh, well, if I know that angle 3 is 120, what's angle 2 worth? No, it's not 120. These are not back to back of each other. But if I covered up half the problem, I would see that angle 2 and angle 3 make a straight line. Oh, straight line, two angles that make a straight line, it's called supplementary. So I do know that 3 and 2, these two angles make a straight line or make 180 degrees. So I could do 180 minus 120 and get 60 here. Oh, so if angle 2 is worth 60 degrees, oh, what's the opposite or the flip of that? 40, angle 4 would also be 60 degrees. So that's how vertical angles works. It helps, it's a property, it's a rule. It's something that helps us figure out a bigger problem later. The last two pair of angles I want to talk about is adjacent. Adjacent simply means two angles that are side by side. It has nothing to do with measurements, it just means that they are side by side. I have no idea what these two angles add up to. I have no idea. It just means that they're side by side. That's it. It's like your backyard is adjacent to your neighbor's backyard. They are touching, they share the same property line. The only way I would know these are complementary is if someone put a right angle box in it. Would be the only way I would know. The last angle property that we want to talk about is this. If I have two parallel lines, what happens? How many angles do I have? So for this picture I have two parallel lines. Parallel, we know, never touch each other. Now what ends up being different is this. What if I draw a third line that intersects both of them? Now this line is special, it has its own name. It is called a transversal. Transversal means trans. The prefix trans means across. So this line is transversing, cutting across two parallel lines. It just is special, so it has a special name. So when we say look at the transversal, we know to look at the one line that cuts through two parallels. Well, what ends up happening is this. I end up with four angles up top. Remember earlier we can number them. 1, 2, 3, and 4. So this is a batch of angles here. But at the bottom I also end up with a similar batch. 1, 2, 3, 4, 5, 6, 7, 8. Now what becomes interesting is how these angles relate to these. If I would pick these 4 angles up, lift them and put them here, they would be the exact same angles. So what we're going to do is talk about just a few definitions here. What I want to look at now is corresponding angles. Corresponding angles are angles that are in the same spot but a different location. And the big thing is they're equal to each other. So let's see what we can do with this. Okay, if I look at these 4 angles, let's look at angle 1. Angle 1 is in the top left of this batch of 4. Top left. So angle 1 is here. Okay, go down in this batch. What angle is also in the top left? Oh, well, angle 1 is in the top left. Guess what? So is angle 5, top left. So that means angle 1 is equal to angle 5. Angle 1, this is the symbol for angle. Angle, it looks like a little L. Angle 1 is equal to angle 5. What is corresponding to angle 4? 4 is in the bottom left. Guess what? So is 8. So angle 4 is equal to angle 8. What about angle 2? Angle 2 is equal to angle 6. And angle 3 is equal to angle 7. Now, how do I use this? Well, let's try one real quick. Okay, angle 1 is 60 degrees. Okay, what angle down here is also 60 degrees? Angle 1 is corresponding to angle 5. So that means angle 5 is also 60 degrees. Now let's use some other rules we know. Okay, angle 5 is 60. What's angle 7? Oh, angle 7 is also 60 because they're vertical. Let's go a step further. Angle 5 is 60. Angle 6 is right beside it. It's adjacent, and it makes a straight line. Straight angle, straight line. Oh, they're supplementary. So if angle 5 is 60, 180 minus 60 is 120. Okay, angle 6 is 120. What's angle 8? Oh, angle 8 is also 120 because they're vertical. You could also go sideways and say, oh, they're supplementary of each other. 60 plus 120 is 180. Now let's go up here. If angle 6 is 120, angle 6 corresponds with what angle up top? Angle 6 corresponds with angle 2. Oh, so this is 120. Oh, if this is 120, then the vertical angle of it is also 120. Side-by-side angles that make a straight line, they're supplementary. 60 plus 120 is 180. 4 plus 3 is 180. They're supplementary, 120 and 60. And also 60 is vertical with 60. So what we want to do is take all of these angle rules. That's all they are. Complementary equal to 90. Supplementary equal to 180. Vertical, back to back, they're equal. Corresponding, same angle in the same spot, different location, with parallel lines and a transversal, they're equal. So can we take this, look at a problem and say, oh, I can figure out what that angle is. I can take that and figure out what that angle is. And maybe we use the idea of a triangle too. Triangles make 180. This plus this plus this all equal 180.